Today's Saturday step question is from Step 1 2019, and it's a question involving trigonometric integration. So this question, we're given three integrals. The first one we're told how to do, and the second and third we have to adapt the method we've learnt in the first part to do the others as well. This question really tests all your knowledge of trigonometric integrals, especially those using sec and cosec. All the techniques really are rolled out in this one. Remember, in step exams nowadays there's no formula sheet, so any formula you want to use you have to know. So the first one, we're going to integrate 1 over 1 plus sine x between 0 and pi over 4, and we're told how to do it by multiplying by 1 take sine x. So we do that. Multiply by 1 take sine x. On the bottom we get 1 take sine squared x, using our hint, which is cos squared x. Split the integral, we get sec squared x minus sine x times cos x to the minus 2. And then we can recognise, hopefully, those two integrals. Sec squared integrates to tan, one of the famous things we know about sec squared. And the other one we can do by inspection, or you might call it the reverse chain rule. It gives us cos x to the minus 1. We then put in our limits. Hopefully we know what the limits are. There's no calculator, no formula sheet, but tan of pi over 4 is 1, and cos over pi over 4 is 1 over root 2. Tan of 0 is 0, and cos of 0 is 1, so we get 2 take root 2. The question was evaluate, and we've done that. So sec squared x is a standard result. We did sine x times cos x to the minus 2 by inspection, but otherwise you might have noted that it's the same as sec x tan x, and you might remember that that integrates to sec x. In other words, sec x differentiates to sec x tan x. Okay, next question. I've already said, often in step questions, the first part is guided, as this one is, and we need to learn something from it for the next parts. So, back to the question. We now want 1 over 1 plus sec x between pi over 4 and pi over 3. It would make sense to multiply the top and the bottom, the numerator and the denominator, by 1 take sec x. It's not the only method. You don't have to do it this way, but it makes good sense. So in the numerator we get 1 take sec x, and in the denominator 1 take sec squared x. Now there are two common facts about sec squared. One of them we've already used, which is that it integrates to tan x. The other is that 1 plus tan squared equals sec squared, and we're going to use that here. To change the integral into sec x take 1 over tan squared x. Then we can split and simplify. So we have the integral of cos x times sine x to the minus 2, which we can do by inspection, take cot squared x. Integrating cot squared, don't know that one straight off, but we do know an identity involving cot squared, which is 1 plus cot squared equals cosec squared. So cot squared becomes cosec squared minus 1. We now have three parts to our integral. The first part goes by inspection, the reverse chain rule, to minus sine x to the minus 1, or minus cosec x. 1 integrates to x, and minus cosec squared integrates to cot x, another standard result. Put in the limits and evaluate. A little bit of simplification using surds, and we end up with pi over 12, add root 2, minus 1 over root 3. So to do this question, you need to know your trig integrals fluently, especially those here involving sec squared and cosec squared, and you need to know your standard trig differentials and integrals to make progress. So the third part of the question, another integral, this time 1 over 1 plus sine x squared between 0 and pi over 3. There may be various methods of doing this, but the one that makes most sense in this question is to multiply the top and the bottom by 1 take sine x squared, which is what I'm going to do. So we get on top 1 take sine x squared, and on the bottom 1 take sine squared x squared, which is 1 take sine x squared over cos to the 4x. Expand the top into 3 parts and split it up. We get sec to the 4x minus 2 sine x cos to the x to the minus 4 over sine squared x over cos to the 4x. If we replace sine squared by 1 take cos squared, we get a further splitting up, and we end up with 2 sec to the 4x minus 2 sine x cos x to the minus 4 minus sec squared x. Given what we've done earlier, we're able to do the second part by inspection. The integral of sec squared is standard. Sec to the 4x is perhaps the new and more difficult part here, and the way it's done as standard is to split it up into sec squared times sec squared and replace the second sec squared by 1 take plus 1 plus tan squared x. So we're integrating sec squared x, which is standard, and sec squared x tan squared x. Sec squared x tan squared x by the reverse chain rule is tan cubed x over 3. The fact that tan differentiates to sec squared gives that away. So overall what we have is 2 tan x, add 2/3 tan cubed x, minus 2/3 cos x to the minus 3 minus tan of x. Put in the limits. Tan of pi over 3 is root 3. Cos of pi over 3 is a half. Tan of 0 is 0. Cos of 0 is 1. The whole thing simplifies to 3 root 3 minus 14/3. A nice question that tests virtually all our knowledge of trigonometric integration. An additional note here, we've just done sec to the 4x. We can apply the same method for other even powers of sec. So sec to the 6x, for example, leave sec squared x on its own and replace the other sec squareds by 1 plus tan squared x. And that will give us 3 integrals: sec squared x, 2 sec squared x tan squared x, plus sec squared x tan to the 4x. The first integral is standard, and the other two are the reverse chain rule. That works quite nicely. You could do the same for sec to the 8x, and you might even find a reduction formula that gives you a general result for sec to the 2n of x. A similar method would work for cosec squared of x. Unfortunately, odd powers of sec x need something different, and I'll let you look that up in your textbooks or notes. So that's today's Saturday step question. I'm David Forster. This is Gold Standard Maths.